Welcome back. In this video, we're going to finish up section 1.2 by doing some examples. So in the first few, what we're asked to do is translate from algebra or arithmetic into English. So the first one, let's just do a few of these. 16 minus 9, that's a subtraction. That would be the difference between 6 and 9. So we'll say the difference. Say if you could say the difference of or the difference between 16 and 9. Okay. 92, let's try that one. The product of 6 and a number is 36. Okay. All right, in the next group, we're to decide if each is an equation or an expression, and an easy way to tell is there an equal sign in there or not? So for this, I'm going to write EQ for an equation. That's an equation, that's an equation, that's an equation, and everything else is an expression. The other way to tell if you're dealing with an expression or an equation is to decide if it's true or if it's an impossible question. So in 98, I can ask you, is it true that 7 times 9 is 63? And you could say, yes, it's true. In 101, I can't tell if it's true or false, not just because there's a value of x there that we may not know, but it's not a complete sentence. Let's say that I told you x was 10. Okay, if I told you x was 10, we'd have 10 plus 9 or 19. Okay, well, that's 19. It's not either true or false. Okay. All right, in the next group, we're simplifying some expressions involving exponents. So let's try that. So for the first one, 103, that's 5 cubed. That's 5 times 5 times 5, which is 125. Okay, note that it's not 5 times 3 or 15. Okay, and then let's see, let's do one more. 2 to the 8th power is going to be 8 factors of 2. And that will be 256. Some more examples here. We're simplifying by order of operations. So we'll just do a couple. So there's not a lot of room here, so we'll do the best we can. I'm going to try 110 first. So here, remember that you can do any two operations at the same time, that is in the same step, as long as they're separated by a operation that's lower ranked. So here we have 3 squared and then a 19 divided by something. And so we could do the 3 squared now, getting 9, because it's separated by the others from the other stuff by that subtraction, which is lower ranked. Okay, so 11 minus 5, we'll do that part in parentheses. Next, get 6. So we have 9 minus 18 divided by 6. Division will come before subtraction. 18 divided by 6 is 3. So we'll have 9 minus 3, 6 for that. Okay, let's see what else will be fun. Usually even and odd problems in math books are paired, so 109 is basically the same question. Let's try 112 next. This one only has multiplications and additions. We can do the 2 multiplications at the same time because they're separated by a lower ranked operation. That's the addition. So 4 times 7 is 28, and then 3 times 5 is 15. So doing this kind of stuff, it's going to be really helpful if you know your multiplication tables. If you are rusty on that, you'll want to spend some time reviewing it. Okay, 28 plus 15, that's 38, 40, 50 for a final answer. And then let's see, 114 looks fun. For 114, it's tempting to say, okay, 4 plus 6 is 10, but you can't do that, right? Because the 6 in here is going to end up getting multiplied by the part in parentheses before the addition of 4 is going to happen. So we'll have 4 plus 6 times 9. Okay, that multiplication will happen before the addition. So 6 times 9 is 54. We have 4 plus 54 makes 58. Okay, and there's that. Okay, let's see, what else will be fun to do? Okay, 123 looks good. Inside of the parentheses, we have a multiplication and an addition to do. Let's do the multiplication first. 9 times 6 is 54, plus 1 is 55. So we'll have 3 times 55 minus 4 squared is 16. Do that now too. Okay, 3 times 55 is 165. 165 minus 16 is going to be 149. Okay, so keep practicing with order of operations. It's an essential skill, and it's fortunately one thing that does get better with practice. Okay, in the next couple of examples, we're evaluating. So we're replacing a variable with a value and then computing according to order of operations. So let's see that. 127, 7x plus 8 when x is 2. That will be 7 times 2 plus 8. Now it's just an order of operations question. 7 times 2 is 14. We have 14 plus 8, which is 22. Okay, and then let's see what else will be fun. 4 raised to the x power. When x is 2, that's 4 squared or 16. In the next couple, there's more than one variable, so that's going to be more exciting. So let's do 137, a squared plus b squared when a is 3 and b is 8. So I replace the a with the number for a and the b with the number for b, and now we can calculate. We have 9 plus 64, which is 70. Okay, combining like terms. Recall that like terms are terms that have the same variable part. They only differ at most in their coefficient. Okay, so to warm up, I guess we're to decide on what the coefficient of each term is. For 8a, it's going to be the 8. For 13m, it'll be the 13. Okay, just the number next to the variable part. Okay, in the following exercises, we're going to identify the like terms. So here we'll have x cubed and 8x cubed are like. And then what else have we got? We have 5 and 14 are the same. Okay, so that was pretty fun. Let's do the one with the r's and s's. It looks like, what's like? We have r squareds. Notice that r squareds and r's are not the same. We have s's though. 10s and 3s are alike. Okay. All right, so now in the next part, we're to identify terms. We'll take 152. The terms are 9y cubed, 5, and y. I don't know why I did that out of order, sorry. For 150, it's 11x squared, 8x, and 5 are the terms. Notice that the pieces that make up those terms are factors. So in 11x squared, the factors of 11x squared are 11, x, and x. The factors of 8x are 2, 2, 2, and x. Okay, just a few more. Okay, so in the next part, we're going to simplify expressions by combining like terms. So 10x plus 3x, that is the same as 13x. Okay, you can also always think of this in terms of the distributive property if it helps you. Remember that 15x plus 4x can be written as 15 plus 4 multiplied by x, and that's 19x. I kind of like just thinking about how it sounds. 4c plus 2c plus c. We're adding up some c's, whatever they are. We're going to end up with 7 c's. Okay, let's try a big one, 161. Here, there's several different kinds of things we're going to add up. Let's take the squared parts first. We have 3x squared and 14x squared. That will make 17x squareds. Okay, I don't know what an x squared is, but I've got 17 of them. Okay, in x's, we have a 12x and an 8x. That makes 20 x's. And then in numbers, we have an 11 and a 5, and that makes 16. Okay, usually it's a good idea to start with the highest powered terms and work your way down to the constants, because that way you end up with an answer that is in standard form, right? So there is that. In the last or next set of problems were to turn from words into math. So this is a valuable skill in working with word problems, definitely, and elsewhere. The difference of 14 and 9, that's a subtraction, 14 minus 9. Notice the directions here. It says translate the phrases into algebraic expressions. That's why I'm going to stop here, just leaving it as an expression. I'm not going to turn 14 minus 9 into 5, right? Because we want to know the translation part. Okay, the product of 8 and 7 is 8 times 7. We could write that in a variety of ways, right? We have several ways of representing a multiplication. The quotient of y and 8 is a division. The sum of 8x and 3x is 8x plus 3x. Okay, some of these are fun. 8 times what? 8 times the difference of y and 9. You make sure you get the parentheses on there correctly. We have 8 times something. That something is the difference between y and 9. Make sure you know why it's not going to be 8y minus 9, which would be the difference between the product of 8y and 9. And let's see what else we have that's good. The quotient of 42 and 7. The product of 9 and 7. Okay, that's good. Okay, last group of these, and then we're all done. Okay, so here, what we're to do, they look like story problems. Let's see 175. Here it says, Eric has rock and classical CDs in his car. Do you have any CDs in your car? I wonder anymore. Eric has rock and classical CDs in his car. The number of rock CDs is 3 more than the number of classical CDs. So we're describing how many rock CDs there are in terms of classical. Let C represent the number of classical CDs. Write an expression for the number of rock CDs. So there's several sentences in here. You'll notice the one that is telling us what to do is at the end, right? So often in math work, story problems, the directions part, the piece that's telling you what to do, occurs at the end. This is kind of unlike the setup in like an English class where when you're reading a paragraph, the topic sentence, what the whole thing is about, is at the very beginning. So take a look at the end sometimes if you want to see what it is you're supposed to do. We're to write an expression for the number of rock CDs. And then we have that C represents the number of classical CDs. So if C is the number of classical CDs, okay, the part that is highlighted now I've already dealt with. So what else? The first sentence is just kind of setting the stage. Eric has rock and classical CDs in his car. So that piece is not as helpful. The next part is the part that is going to answer the question for us. The number of rock CDs is 3 more than, that sounds like an addition. It's 3 more than the number of classical CDs. So C plus 3 will be the number of rock CDs. Okay, so the next problems are going to be really similar, but let's try them. Okay, 176. The number of girls in a second grade class is 4 less than the number of boys. B will be the number of boys. We're to write an expression for the number of girls. So the directions again occur at the end. We're told B is the number of boys. And then the number of girls is 4 less than the number of boys. So if there's 10 boys, there would be 6 girls, right? So the number of girls would be boys minus 4. Okay, so there is that. Let's see. Oh, this will be fun. 177. Greg has nickels and pennies in his pocket. The number of pennies is 7 less than twice the number of nickels. Let n be the number of nickels. Okay, write an expression for the number of pennies. So how can we describe how many pennies there are using the number of nickels? And that's where the piece that is underlined is going to help. The number of pennies is, that's equals, right? The number of pennies is 7 less than twice the number of nickels. Be careful with less than because the order on subtraction makes a difference, right? It's not commutative. And so you have to make sure that you're getting the subtraction done in the correct order. So 7 fewer than or 7 less than the number of nickels. Okay, last one, and then we're all done, okay? Jeanette has $5 and $10 bills in her wallet. The number of fives is 3 more than 6 times the number of tens. Let T represent the number of tens. That is how many bills there are. Okay, we're to write an expression for the number of fives. The number of fives is 3 more than 6 times the number of tens. Okay, so that's our final answer there. F is equal to 6, 3 plus 6t. Just for fun, let's figure out the value for these. That would be fun. So t is the number of tens. We don't know how many tens there are. So we actually cannot. I'll do the total value. The value of the tens, we could do that, will be 10 times t. Remember that the number of bills there are and what their value is are 2 different things. Okay, the number of fives will be 5 times f, and that's the same as 5 times 3 plus 60. Okay, all right, just for fun. All right, so that takes us to the end of section 1.2. Let me know if you have any questions, and then have a great day.